Okay, so today we're going to look at this problem. So it's just a couple notes here. First off, I'd done a live stream with this earlier, but it crashed, and when it crashes, it doesn't save it, unfortunately. So this is kind of just a video made for YouTube. That being said, I wanted to make a quick couple announcements. Announcement number one, I'm going to be starting to use Google Classrooms starting April 13th. So I'm going to use Google Classroom, but I'm going to still continue to use Discord. But I will no longer be using my website to post assignments and things like that. So in order to find out information regarding my classroom, assignments, things like that, you'll either have to go to Discord or the Google Classroom. Okay, that being said, let's move on to number 9 today. So this should be so when I say it's a familiar problem, it's familiar in that we've done kind of this type of problem before, but it definitely has some things that we haven't done also. So let's see what we can do with this one. So we got a coffee pot. It has a shape of a cylinder with a radius of 5 inches. H is the depth of the coffee pot, measured in inches, where H is a function of time, measured in seconds. The volume of the coffee pot is changing at a rate of this. And they gave us, this is kind of like a hint, hey, look, the volume equals this. So let's see what we got here. So the first thing we got to do is we got to show that dH dt equals this. So how are we going to do that? Well, the way we're going to do that is we're going to take the function given. So I'm going to take the function v equals pi r squared h. And then when I think you guys agree, when I take the derivative of this, I will get something with a dH dt, and I can solve for dH dt. But before I do that, couple of things. One, it's important to notice regarding r. So I'm just going to put a little kind of note here. R is a constant. And here's what I mean by that. Notice what changes as time goes by. I think you'd agree, as time goes by, the height, right? As you know, as water or coffee goes into this thing, the height's going to change. So h is a variable because it changes as time goes by, right? The volume of this thing as time goes by changes, but the radius never changes, right? It doesn't matter how much liquid is in this coffee pot, the radius will always be 5. So it is a constant, which means I have to treat it like a constant, okay? So for example, when I take the derivative of constant, right, derivative of constant is 0, or if I want to use it as a scalar, right? But it is a constant. So what I'm going to do instead, or what I'm going to do is, because r is a constant, I'm going to plug it in right off the bat. So I'm going to say the volume equals pi 5 squared, which is 25, times h. Okay? So let me just clean that up a little bit. I get volume equals 25 pi h. Perfect. Next, time to take the derivative. Now I'm going to do this with respect to t. So I get dv dt equals 25 pi. Derivative h is dH dt. So from there, right, all I'm going to do is solve for dH dt. But we are told that dv dt, this right here, equals this, right? Because the volume of the coffee of the pot is changing at a rate. So that's the rate of change of the volume. So I can replace that, time to replace it. So I get negative 5 pi times the square root of h equals 25, that's not a 5, 25 pi dH dt. So dividing both sides by 25 pi, I'm going to get negative 1/5 times the square root of h equals dH dt, which is exactly what they wanted in part A. Okay? Next. The next thing they tell us is we have this function, given that h, they give us this initial condition, h equals 17, well, t equals 0. we're supposed to solve the differential equation that they gave us for h. Now that means we're going to write h equals blank. We have done this quite a bit already. I think you guys would agree. We've done this in the last few problems. So let's go through and do that here. So I'm going to get rid of everything here so I have some room to work. And let's do it. Okay, so we are given dh dt equals negative square root of h over 5. So I'm going to use separation of variables to rewrite this with h's on one side, dt's on the other, or t's on the other. So I can say dh divided by the square root of h equals negative 1/5 dt. And then from here, before I integrate, I'm going to rewrite this a little bit. So I'm going to say, how about h to the negative 1/2 dh equals negative 1/5 dt. Okay, now it is time to integrate. So I'm going to go and take the antiderivative of both sides. And on the left-hand side, I get 2h to the 1/2 equals negative 1/5 t plus some c. And since we're supposed to write this in terms of h, I'm going to go and solve this for h right now. So I'm going to divide both sides by 2. So I get h to the 1/2 equals, negative 1/10 t. C divided by, so if I'm going to write this as c1, I think you'd agree that a constant divided by 2 is still a constant. It's just some other constant. So I'm just going to call it c. And then I'm going to square both sides. So I get h equals this stuff. Okay, next we're going to take the initial condition and plug it in. So we're going to be plugging in the point 0, 17. So I get 17 equals negative 1/10 times 0 plus c squared, which means I get 17 equals c squared. So the square root of 17 equals c. Now technically it is plus or minus, but this has to do with, we can get rid of the negative because, what is this? This is representing the volume of something. So you're not going to have a negative 17 in here. That doesn't make any sense in the context of this problem. So what I'm going to do from here is I'm going to take that root 17 and I'm going to plug it in to this formula right there. And I get h equals negative 1/10 t plus root 17 squared. Okay? Finally, letter C. At what time is the coffee pot empty? They are asking for a position, right? When is it empty? When is there 0 coffee in the coffee pot? That's a position function. So what we're going to do is we are going to take the function that we just created, this one, and we're going to set h equal to 0. So I'm going to say 0 equals this stuff. And I'm going to solve for t. So squaring both sides, I get 0 equals negative 1/10 t plus root 17. Sorry, I took the square root. I didn't square both sides. I took the square root of both sides. I know the math comes out the same, but just to be precise. So finally, I get t equals 10 times root 17. And that's it for today's problem.